Hi everyone, we are going to finish off this chapter, finish off this section with a video on how all of these functions kind of put themselves together. And we are going to look at them through some more complicated problems. And to do that, we're going to kind of look at, for example, a few things. So I'm going to look at the sine. What would happen if I took the sine of the inverse sine? Okay, and I'm just going to talk through it first of all and discuss it. So this is going to give me, starting on the inside, because order of operations says we start on the inside. So the inverse sine of 0.5 is going to give me the angle to which the sine is equal to 0.5. And then I'm going to take the sine of that angle. Well, that's going to give me that 0.5. So this is giving me a value for, okay, so think about it. Inverse sine of 0.5 equal to y means that the sine of y is equal to 0.5. Y is going to be this answer. So now I also know that the sine of y is 0.5. So these undo each other. So the sine of the inverse sine, or the cosine of the inverse cosine, or the tangent of the inverse tangent, will be this x value, provided x is in the domain of what you're starting with, okay? Because we have to be able to figure that out first. So we have to make sure that x is in that domain so that we have a valid answers. Some other things we can do. It does not work very nicely this way though, and I'm going to show you a couple and we'll actually do them. This one works a little different. This is almost always x. It is equal to x provided we are inside, provided that our x is between a negative pi over 2 and pi over 2. If we're outside of that region, something else happens, and we'll kind of go through that. So I'm going to kind of just work through one to begin with. And I usually work through these and don't remember these little rules. So let's say I want to know the inverse sine of the sine of pi over 3. So I'm going to actually do this. So what is it going to tell me to do? So I'm going to say, okay, the sine of pi over 3. Pi over 3 is in my first quadrant. It is a 60-degree angle. Pi over 3, 60 degrees. 60 degrees is that 1, 2 square root of 3. 60 is the biggest angle, so 30 is up here. So this is my 1, 2 square root of 3. So that means I'm looking for the inverse sine of square root of 3 over 2, or what angle gives me that sine? Well, pi over 3. So if I'm in this first quadrant, everything works out beautifully. Things are a little different because of the restrictions of our sine and so forth, and, or I should say inverse sine, where how we have to restrict it. Starting with this one, 7 pi over 6 is, well, that's bigger than pi. That puts me in this quadrant right here. And that's going to be a pi over 6 reference, which is a 30. 1, 2 square root of 3. Both of these are negative because we're in that fourth quadrant. So I'm going to be looking for the inverse sine of a negative 1/2. Well, the inverse sine function always gives me angles in the fourth or the first. So what it's going to do is it's going to take these angles in these other quadrants and move them into the quadrants where the sine is going to be the same. Sine as in positive negativeness. So this is going to take this triangle here, and we would then get a negative pi over 6. So we do have to be a little bit careful when working with the inverse of a regular value. Okay, so let's just do some more here. Cosine of an inverse cosine of 3. Again, when we do the regular function of the inverse, it works so much nicer. However, we have to be able to calculate the inside piece first. So we have to be able to calculate the inverse cosine of 3. The inverse cosine would be asking ourselves, what angle do we get a cosine equal to 3? Well, that does not happen because the cosine always gives us values between -1 and 1. So the domain of the inverse cosine is -1 to 1. This is outside that domain, so this one does not exist. Okay, let's just do some problems and practice and see how we do. And I'm going to throw some other trig functions at us. And I'm going to mix up the sine and the cosine. And do these values. And we're going to do these all without a calculator. Because we're going to be working with triangles. And some of these will be triangles we know. Some of these may not be triangles that we know. Okay, so I'm going to talk through them so that we can kind of get an understanding. So we're starting on the inside. Inverse cosine means I'm talking about an angle where the cosine of that angle, I'll call it A, is equal to a half. So cosine is restricted, since we're talking inverse, first and second. It's positive. We're in the first. So that means I have a 1 and a 2, which does give me that square root of 3. So I'm talking about this angle right there. And now I want to take the sine of that angle. Sine is opposite over hypotenuse. Notice I did not need to know what angle this was. So I can do these without a calculator, just knowing the Pythagorean theorem. This one happened to be a triangle that I knew, but it wouldn't have to be a triangle that I know. So let's just do another problem. Let's just do the cosine. I'll switch these two up. The cosine of the inverse sine of, and let's just go with, I don't know, I'll even do a negative here. A negative, let's go 2/3. Why not? Okay. As long as I can calculate this, and I can calculate this inside part as long as this is between -1 and 1, and that is. So inverse sine is restricted to the fourth and the first. Since it's negative, I'm down in the fourth. Sine is opposite over hypotenuse. This is not a triangle, I know, but I don't care. I can still do this. So I can find this value by taking, 4 plus 9. This would be the square root of 5. Okay. I want to find the cosine of this triangle. Cosine is adjacent over hypotenuse. Yes, I could plug that into a calculator. Yes, it would work. However, it would give me a decimal. Unless you have fun calculators. Okay, let's do some more. These are fun. Okay, I think they're fun. You guys might not think they're fun. Let's do the inverse cosine of the tangent of a negative pi over 4. Okay, starting on the inside. Notice I have a regular tangent. So this is an angle, and this is where you really start learning, what am I working with? What am I getting out? Where am I at? All of those little things, all those little details start getting more and more important. It's all about the little details. Okay, so inverse or tangent of a negative pi over 4. Negative pi over 4 is right here. It's your 45-degree angle in the negative direction, which is a 1 square root of 2, this being negative because it's going down. So we're going to be doing the tangent of that. Tangent is your opposite over adjacent. Okay, so now I want to calculate the inverse cosine of a negative 1. So where is my cosine curve? What angle? This is asking for an angle. Gives me a cosine equal to negative 1. And I remember the curve, cosine curve. So where is my cosine negative 1? It's down here, which is this value right there, which is pi. Okay, I think I can squeeze one more over here. Let's do, now let's do the cosecant. I haven't seen that guy for a little bit. And let's do the cosecant of the inverse tangent of a negative 3. Okay, the inverse tangent we can calculate always, because that's domain is all real numbers, because that's the one that had those two beautiful horizontal asymptotes, took on every x value as it went out. Don't have very many y values coming back, but that's okay. But this is going to give me an angle. Okay, so I'm going to draw a triangle in either the fourth or the first, because inverse tangent is restricted to the fourth or the first, getting the angles coming out. Since it's negative, I'm down here. Tangent is opposite over adjacent. This is where my negative is, because it's going down. Using Pythagorean theorem, 3 squared is 9, plus 1 is 10, so this is going to be that square root of 10, which does not simplify. Cosecant is 1 over your sine, or your hypotenuse, over that opposite. And I'll put the negative out front so I don't lose it. So we get a negative square root of 10 all over 3. Very nice problem. Hopefully this helps show you that these problems take time, and they will help you learn those little details, those ideas more and more. So you do need to practice. This does take time, but you need to practice.